The reason why I've put in this first question is just to check that it's just a bit of a check to actually realize what we're doing, okay? A balloon is blowing up at a constant rate of 200 cubic centimeters per second. What does 200 represent here? It's blowing up at this rate. That's the volume, and that's how it's changing over a second. Yeah, each second or time. Right? So dV/dt, the volume, the change of volume with respect to time is actually just 200. Right? Just to check that we actually know what we're doing here, right? Rather than trying to overthink things, do we actually know what dV/dt represents? That represents how the volume is changing over time. Okay. But this question now is saying, part B is something slightly different. It's saying find the rate at which the radius is changing when r equals to 15 centimeters. So Callum, for this one here, when I want to find the rate at which the radius is changing, what expression is that equal to? That's how r is changing over time as well. dr/dt, okay? So let me just finish this off. dr/dt is over here, right? That's what I'm trying to find. What I need you to do for me is I need you to think about, okay, dr/dt as a subject or dr/dt as a piece. I've actually seen that before. Where have you seen that? You've seen it over here, right? So have a think. Okay, if I have dv/dt is equal to dv/dr times dr/dt, right? I'm looking for this piece. I actually have this piece already. Can you go from there and find out what dr/dt is for me? Okay, that's your homework for me as well, including 8.11. Okay, so once I've got all these pieces here, what I want to be thinking about is where do I actually get them from, right? I'm looking for dr/dt because I'm looking for the rate at which the radius is changing when r is equal to 15. But what do I have? I have dv/dt is equal to 200. dv/dr is something I don't really have, but if you remember from the previous question, right, we know that an expression for volume is 4/3 pi r cubed. And so dv/dr, I can use that same idea. Take the derivative, and once you do that, you get 4 pi r squared, so I can substitute that in, times dr/dt. And this time, the question is slightly different because we're looking for dr/dt, which is over here, but it's not the subject of the equation, right? So thinking about your normal algebraic processes, to make it the subject, right, you just want to divide both sides by 4 pi r squared. So I get 200 over 4 pi r squared is equal to dr/dt, okay? And so that's my expression for dr/dt, but I'm looking for when r is equal to 15. So at r equals to 15, I've got dr/dt is equal to 200 over 4 pi times 15 squared. And you can put that in your calculator, or what you might want to do is, again, you can leave as an exact value, right? So if you put in the numerical values as an expression, we've got 200 over 4 times 15 squared. That actually simplifies to 2/9, or you can say that's 2/9 pi. And if you're thinking as a rate, right, we're looking at the rate at which the radius is changing. This is all in centimeters. That's 2/9 pi centimeters per second. Okay, so that's how we have all these little pieces, and we're putting them together to find what is the rate at which the radius is changing. But we don't have to just leave them at spheres, right? We've been looking a lot at spheres, but we can also look at all kinds of, really any kind of 3D shape where we know the formulas and expressions, right? Let's take this one. We've got the volume of a cube, and it's increasing at 23 cubic millimeters per second. We want to find the increase in its surface area when its side length is 140 millimeters. So the increase in surface area over time, I'm thinking that I'm looking for dSA dt. That's what I'm looking for. I'm trying to find the rate at which the surface area is changing over time, right? But the problem is I don't really know what parts I'm going to put into here. I know I'm going to try and use the chain rule of some sort here, but what I want to think is, what information do I have? Well, first of all, I know that the volume of a cube is increasing at 23 cubic millimeters per second, right? So that's how the volume is changing over time. So that's dV/dt, and that's equal to 23. So just jot that down there. What else do I know? I think the fact that we need to use dV/dt and dSA/dt, it'd be helpful to have the formulas for the volume and the surface area, right? So for example, I've got my cube here, and I'm thinking, all right, what's an expression that kind of relates the side length of the cube, like one of the variables that's a part of the cube, the side length, let's call that L, and the volume and surface areas, right? So volume I know, well, if you want to find the volume of the cube, we just multiply all the side lengths together, right? So we've got the height, width, breadth, and that's going to, or length, sorry, and that's going to be L cubed. And what else do we have? Well, we know that the surface area, if you think about the surface area, you're looking for the faces, right? So I've got L squared would be the area of one face. And you think about, okay, I don't have just one face on the cube, I've got 6 different faces there. So I need to multiply that by 6. That would be 6L squared there. Okay. So I've got these kind of expressions here. At the moment, I'm just kind of going all over the place with these different expressions that I have, but I really want to think, how can I start putting these together? And I want to be thinking about these different pieces that I have. I want to find dSA dt somehow. How am I going to do that? Let's get some more space. Okay, so I've got these expressions here. I know I'm looking for, at the end of the day, dSA dt. What I might be thinking is, okay, we're working with derivatives. Let's think about how is the volume changing with respect to the side length, right? So I could take dV dl, and that would be 3L squared. So that's another part that I could use. And same thing over here, I've got, if I take the derivative of this, I've got dSA dl, and that would be 12L over there. Okay, so I've got all these pieces here. And I guess the hard part about a question like this is it's not really clear which direction we might want to take. There's a few different ways you can go about it, right? At the end of the day, I'm looking for dSA dt, and I want to be thinking about the chain rule expressions that I can be using here. dSA dt is over here. Okay, I want to be introducing another variable, right? And we have another variable, we've got our length. So I could be looking for dSA dl, which I already have, multiplied by dl dt. Right, and the reason why I chose that is because I have dSA dl over here, and I know if I put that over there, then I need to multiply by dl dt in order to actually simplify that through to end up with that. So that's the kind of goal that I'm working towards. I don't actually have that right now, right? Because I have dSA dl, dl dt, I don't know where that's going to come from. That's where this comes in. I might actually have to create another separate equation over the side here, right? I've got dV dt over here. And dV dt, I can write another way, right? I can write dV dt as dV dl times dl dt again, right? Why is that more helpful? It's actually helpful because I actually have dV dt over here. dV dt is just the same as 23. So I can put 23 over here. Okay, it's a constant value. The volume is always increasing by 20 cubic millimeters per second. And we're going to find the increase in surface area when its side length is 140 millimeters. So I'm going to take dV dl, which I know is 3L squared, multiplied by dl dt. And again, we want to make dl dt the subject because that's the piece that I was missing there. So dl dt is equal to 23 over 3L squared. Okay, so we've got our expression for dl dt over here now. Now we can go back to this and we can say, all right, what pieces do I need? I need a dSA dl, that's 12L over there, multiplied by dl dt, which I have over here now, that's 23 over 3L squared. And that's just the expression though. I'm actually looking for when its side length is 140 millimeters, right? So I can say at L equals to 140, that's the side length, then dSA dt is going to be equal to 12 times 140 multiplied by 23 over 3 times 140 squared, just substituting all that in. And when you put that in, you might get a pretty small value. Yeah, we get 0.657. Let's just round that off to 2 decimal places, 0.66. Think about what units we're working with. We've got millimeters here, and we're thinking about how the rate of its surface area is changing. So that's going to be square millimeters per second. Okay, so that's how you can take a question where it's not necessarily clear the route you have to take, but just putting all the information in front of you can help you find a path to get to your answer. Okay.